1780 plus 710, all multiplied by 14.5 meters per second. So what do we get for those numbers? So this looks like about 1,000.4, looks like about 5 or something. 6.2 meters per second. So in other words, the truck slows down. So does that seem reasonable that the truck slows down after it hits the car? Seems reasonable, doesn't it? The truck's moving, it hits the car, the truck will slow down after the collision. It's losing some of its momentum. What about the car? Now this is about 34, 35 over 25. This is going to be more than 1. So what is this, about 20 something? Because I can see that this ratio here is greater than 1. It's about 3,500 over about 2,500. So looks like we're getting about 20 something, 22, 23. That's all in a bracket. So what is this number? 20.7. Is it 20.7? Does that seem reasonable that the car will actually go faster than the truck that hit it? Yeah. So you're sitting in a car, right? You put the car listening to the music, right? Radio, texting. Right? Truck comes along and hits you. Would you expect to move off fast?
Yes.
Yeah, I think that's reasonable, isn't it? That the light object, when it's hit by a heavy object, moves off pretty fast. If you're on a bicycle, you may fly off really fast. So I'm not surprised that I get a number that's pretty big there. Let's see if 20.7. Correct. So notice that these two formulas that we use are both consistent with conservation of momentum and conservation of kinetic energy. So don't forget that when we derived these two formulas, I did quite a lot of algebra when I did this in class, and to derive these formulas, I used two things. I used conservation of momentum and conservation of kinetic energy. So even though the car moves off faster than the truck that hit it, it's still consistent with conservation of momentum and conservation of kinetic energy. They're both conserved in an elastic collision. So these two formulas, which we derived, you don't have to memorize them, but you need to be able to use them. Okay, well, I think we have time maybe for one more question. So I want to, yes?
Oh, this is going to be chapter 6, part 3, number 4.
So chapter 6, part 3, okay. Chapter 6, part 3. This is about equilibrium forces. And what's the number?
4.
The 4. Does it say 6.26?
Yeah.
Oh, about the broken leg?
Mm-hmm.
Yeah, so this one, well, I've done it already, I've got the answer. So for this one here, yeah, we have to look at the forces. So what is the force that's being exerted on this rope here? So this is a weight that's hanging freely, isn't it? So you got, here's your broken leg. There's a weight here that's hanging freely. So what's the force exerted by this mass M? It's going to be mg. So the tension T is pulling up the rope is equal to mg. So the tension T2 throughout this rope is equal to mg. So you've got an mg in the rope. Now, is it mg that pulls along in this? So you look at the direction of the force. Because if you've got a broken leg and you want to repair it, you presumably have to apply a force. Does that help repair the broken bones? And you want the force to be along in this direction, F. Along in this direction, F. So what is it going to be? T2, is it going to be a sine or a cosine? T2, is it going to be cosine of that angle, which is 30 degrees? So T2 cosine 30 degrees is pulling in the direction along the direction of the F. What about T1? What is the force T1? Isn't it in fact the same we've got T1 cosine 30 plus a T1. T2 cosine 30 plus a T1 cosine 30. That's the total force acting on him. So he's got a T2 cosine 30 pulling in the direction of that, and a T1 cosine 30. How do we calculate T1 and T2? Well, they're both equal to mg. And do they tell us m? They said m is 2.27 kilograms. So if you read through all the question, you get to here. So if you know what m is, both those tensions, T1 equals T2 equals mg. Because can you see how the force is the same throughout, or the tension is the same throughout this rope? So if you follow the rope around, the rope is T, has a tension T, and that T must equal mg. So the greater the mass that's hanging, the greater the tension in the rope. So if you know the mass, you can find the tension, put them in there, and that's going to give you the force. So I think that's how you calculate that. Now, I just want to remind you that we have, that you'd want that our exam is in 7 days, right? It's the 18th, Tuesday the 18th. If we start at 10:15, you know that's the starting time. It's not the regular time, so we check your exam schedule. Am I right, 10:15?
Yeah.
Right in here. And so don't forget to bring calculators, spare battery if you need, pencils, erasers, rulers, the usual things. Well, it's a 2-hour exam, so I think you can expect something, proportionate to what we've had. How many questions have there been on the midterm exams? Something like 8, something like that. So, probably proportional to that, about 12, I would think, something like that. So look, we've covered many things. You've got 7 days. I wish you luck in preparation, and I certainly hope that we can get rid of these other problems which are highly unpleasant, and I hope we can put those behind us. So anyway, I wish you luck, and I'll see you for the final exam. If you want to come and ask me any questions, welcome. I'll see you next Tuesday.